Hello and welcome to Robotics in a Nutshell, our series of robotics tutorials sponsored by RS Grassroots. I am Jordan from Humanoid, and in this series we will go over the design, simulation, manufacturing and testing of a bionic finger. The goal of this series is to get you up to speed in the field of robotics as quickly as possible if you have no previous experience. Before we start, I'll take a minute to introduce Humanoid and myself. Humanoid is a University of Edinburgh-based robotics club that aims to create the first Scottish humanoid robot. Currently, we are developing biologically inspired or biomimetic arms and hands. As for me, I'm the project leader of the ARM team, which is working on an exoskeleton whose software and hardware will be the basis of the arm. Our development is done this way to ensure that our final design will be safe to interact with people. The end result of this series will be a humanoid finger actuated by a servo motor controlled by an Arduino Uno microcontroller. It will have 3 sections, which are assembled just by snapping them in place. Although it might seem simple as far as robots go, in order to actually build this finger, you will need to know how to design parts using a computer-aided design or CAD program, how to 3D print parts, how to make simulations of mechanisms, and how to write code to control the motor with the microcontroller. And this tutorial series will teach you exactly that. First, we need to design the finger. Today, we will go over the functionality of a computer-aided design program called Onshape, and we will design the middle section of the finger. I highly recommend that you replicate the tutorial after initially watching the video, since practice is by far the best way to learn any sort of CAD program. Since Onshape is a free browser-based CAD program, you won't need to install or buy anything. All you need to do is to make an account. Just follow the link on the slide. With that out of the way, let's proceed with the tutorial. Once you've made an Onshape account, you'll be greeted by this screen from where you can access your projects and a bunch of other things. If you need to adjust your preferences like changing your units, you can do so from the My Account menu under your username. Today we'll be working in millimeters. Now let's get to designing. Click on Create in the top left corner, then Document and give your file a name. You are now seeing the Part Studio Workspace. It contains 3 planes and origin which serve as the basis for every Onshape project. Over the workspace, there is a toolbar that contains tools for designing parts, and to the left you can see a sidebar that lists the objects in our workspace. To navigate the space, use right mouse button dragging to rotate your view and the middle button to pan it. You can also click on the view cube in the top right corner to view the workspace from a particular angle or to reset your view in case you get lost. First, we will need a 2-dimensional outline which we will use to create 3D geometry later. Create a sketch by clicking on the label top left button and select the right plane as its plane. Right-click and select View Normal to the sketch plane to face the sketch. Hide the planes from the feature sidebar so our view isn't cluttered. Now we can proceed with our first sketch. On the toolbar you can see a variety of sketch-centered tools. Let's start with the circle. Left-click on the circle icon and then on the origin. Left-click again to set its diameter. Now we will create a line by clicking on the line icon and 2 points followed by Escape. And another circle at the other end of the line. To give the line a precise length, select the Dimension tool in the right half of the toolbar, click on the line and enter 22 mm. You might have noticed that while our line is black, the circles have a blue outline. This is because our line is fully constrained, as in its length and position are fully determined by dimensions and constraints, while we haven't set the diameters of the circles. As a result, we can adjust them by holding down the left mouse button and dragging. We will now set some constraints which determine relationships between sketch elements. In our case, we want the circles to be equal. To do so, we click on the Constraints drop-down menu next to the Dimensions icon, select Equal, and click on the two circles. Now they have the same diameter, and upon dragging one circle, the other matches its diameter. Now we need to set the diameter of one of the circles to fully constrain them. Click on Dimension, click on the circle and set the diameter to 12 mm. Now our circles are fully constrained. Next up, we will create two lines. This time, in order to fully constrain them, we will use the tangent constraint to make them tangent to both circles. After creating the lines, click on Tangent for the Constraint drop-down menu, and then on the respective line and circle you want to make tangent. Repeat that for both lines, setting each to be tangent to both circles. Now we would like to get rid of some unnecessary lines. We can do that using the Trim tool, which can be used to remove line sections intersecting other lines. Once you select the tool, remove the inner circle arcs. Don't worry about the dimensions and constraints we set to the circle earlier. They are not removed during trimming. Finally, we'll make two circles at the ends of the line, which will serve as sockets for the joint of the finger. These circles will have a diameter of 5. Now we are done with our first sketch. We can close it for now by clicking on the green tick mark and start creating some 3D geometry. We will begin with arguably the most often used tool for 3D geometry, the Extrude. It essentially gives thickness to an enclosed sketch profile. Click on the Extrude icon to the right of the sketch button and select the finger outline. You can see a visualization of the geometry we'll get. By dragging the arrow you can adjust its thickness, or by setting the depth in millimeters. In our case, we want to extrude in both directions and at the same time, so click on the symmetric checkbox. Set the depth to 12 mm and click on the green checkbox to complete the extrude. We now have our first 3D object in our workspace. You can see that in the sidebar we have an extrude feature as well. We can go back to it if we need, but we will undo the extrude feature instead with Ctrl+Z. Right now we need some more details in our sketch to actually turn it into a finger section. To look at the sketch, you can either right-click and press View Normal to the sketch plane as we did earlier, or just click on the corresponding side of the view cube. We will first create a line through the middle of the part. We can snap to the midpoints of lines, which is very convenient for this. Create a second vertical line to the side of it. Instead of creating another line on the other side, we can use the mirror tool for that. It's one icon to the right of the trim tool, and after selecting a mirror axis and an object to be mirrored, you can see that we saved ourselves a few clicks. Let's set the distance between them to be 9, and as you can see, when one line moves, the other does too due to the symmetry constraint created by the mirror. We will make another mirror operation with this line, which is 1 mm away from the top line of our finger. As a mirror axis, we will use the line that is connecting our circles. By hovering over the area, you can see that we've created quite many enclosed profiles here that we don't really need to select individually. Since the line connecting the circles and the line through the middle of the part are only there to help us create other sketch elements, we can select them and use the construction tool to mark them as helper lines. Now if you hover over the area with many profiles previously, we can see that the construction lines don't participate in profiles. Construction objects are only there to help us with making the actual geometry. We can now close our sketch and get back to creating 3D shapes. Let's select all profiles and again create a symmetric extrude with a depth of 12 mm. We now want to remove some material around the joints of the finger so it can move. Let's create a new extrude, hide this part temporarily, and select the areas we want to remove material from. Set the depth to 8. Now, once we make the part visible again and select Remove instead of New, we can see that material is taken away. Let's also do the same for the small channels on the top and the bottom of the part in the same manner. Now our part is looking much more like a part of a robot. It's good practice to rename your parts to something descriptive so you can orient yourself in workspaces with many parts. You should also do the same for your sketches and, if possible, group features like extrudes into folders to keep your sidebar clean. This can be done by selecting the features you want to group, right-clicking and pressing Add Selection to Folder. Finally, let's add some more polish to our part by rounding off some edges. To do so, select the Fillet command and select an edge. You can see that it's now a nice rounded off transition between the two faces of the part. Let's select the other 3 inner edges and make the fillet radius 1 mm. The other option for modifying edges is chamfering, which instead creates a flat face at equal angles between the faces that form the respective edge. The chamfer tool is to the right of the fillet tool. Here, it creates a 45-degree angle between the two perpendicular faces. Let's say you want to select multiple smoothly connected edges, like this edge loop here, for example. Both the chamfer and fillet tools are smart enough to detect that to save you some time with selecting edges if tangent propagation is selected. Let's finish off this part by using this to our advantage. Finally, let's add the fillet and chamfer to the middle segment folder. And with this, we're done for our first part. With this knowledge, you can now design plenty of parts in Onshape and explore the tools on your own. In the next video, we will work with some more advanced tools to make the rest of the finger quickly. Thank you for watching and good luck with your robotics journey.